Day 2 of the inaugural Northeast Pennsylvania Innovation Conference. As Don may have mentioned, my name is Eric Custoden. I'm President and CEO of the Northeast PA Industrial Resource Center, perhaps better known by our acronym NEPA. Since 1988, NEPA has been providing small and mid-sized manufacturers with the technical expertise and consulting they need to grow and thrive. One of the ways in which we do this is to accelerate their awareness of, evaluation of, and adoption of new technologies. And it's in that context that we're eager to be a gold sponsor for today's event. We appreciate all that Don, Rodney, and the team did to put this great event together. Let's give them a hand. Our regional manufacturing community continues to flourish. In fact, 2015 marked the third consecutive year of regional manufacturing job growth. Our clients alone last year were able to create and retain over 1,500 full-time manufacturing jobs. It's accomplishments such as these that allow manufacturing to retain its position as our third largest industry in terms of employment and second largest industry in terms of total regional payrolls. We know one thing, it's communities that bring together three critical economic development drivers: the existing businesses in advanced manufacturing, the budding entrepreneurs, and the R&D and innovation capabilities at higher education institutions are going to continue to thrive in the years ahead. When you look at successful regions, the one thing that they have in common is that they manage to bridge the gap and get those three critical drivers talking, communicating, and collaborating. And it's events such as this that allow that to happen. We look forward to today as a way for you to learn, to network, and to collaborate. And we very much hope that you will continue those communications well into the future to grow your business, your suppliers' businesses, and those budding entrepreneurs that are critical to our long-term sustainability and growth. To kick off today's sessions, I'm pleased to introduce our morning keynote speaker, Robert Zabricki. For that, I'm going to need some notes, as I believe Robert provided me with a single-spaced bio for himself, which I very much appreciate. I'll do my best, Robert, and I do have his permission to call him Bob, to paraphrase some of his great accomplishments, and I'm sure he'll supplement that which I forget. Bob joins us to share his experience in leapfrogging from effective manufacturing to additive manufacturing in the context of TE connectivity. TE connectivity is a world leader in harsh condition connectivity components that recorded over $12 billion in sales last year, and through innovation and entrepreneurship has amassed some 13,000 plus patents. He started with TE Connectivity when it was just a machine shop back in 1979 and helped migrate that company from a machine shop to using CNC technologies, and then eventually got into additive manufacturing technologies. He's going to explain for us the start of 3D printing within the company and how it's used today as a critical tool. I should also mention that he is the participant in and winner of 2 distinguished awards from AMA, the Additive Manufacturing Users Group. So if you heard that acronym AMA yesterday, it's not just a cool, trendy coffee shop, it's actually the Additive Manufacturing Users Group. He served there as chairman, vice chairman, secretary, and is now past chairman emeritus, and he won their Dinosaur Award back in 2004 for distinguishment in stereolithography. And he was also their President's Award winner in 2010 to evidence his commitment to additive manufacturing and the Users Group itself. He attended Harrisburg Area Community College, so many good things do come out of Harrisburg. And he was recently very instrumental in bringing additive manufacturing to that college as well as to Penn State's Harrisburg campus, which I'm sure those students and faculty very much appreciate. He's avidly involved with students. He often mentors and allows students from Drexel, Lehigh, and other universities to shadow his work, and he's currently working with interns from Harrisburg Area Community College. So thank you very much for that.
Okay, now that everybody's settled down and in their place, I want everybody to jump out of their seats, run up here and grab one item off the stage. Come on, we're at Kalahari. Act like an animal, please. Everybody take one, and then after everything's over, during break, if there's anything left on the stage, come up and grab it. A couple little trinkets, buckyballs. The flat thing there is called a rattleback. You spin it counterclockwise, it automatically turns clockwise. The gear itself, we're going to be talking in detail about the gear. Look at that planetary gear closely. One side of the planetary gear says 2016, the other side says Northeastern, or NEPA IC, Northeastern Pennsylvania Innovation Conference. Okay, I work for TE Connectivity. At TE Connectivity, we are a $14 billion company. We have 80,000 employees. We're in 150 countries worldwide. With that said, within additive manufacturing and TE Connectivity, we feel like we contribute a lot to the industry within additive. And I got into it right around 1989 and 87. And as the previous speaker said, the invention of stereolithography was 1983 when the patent was given. 1987, we were one of many companies here that beta tested the technology. Now, we beta tested it in North Carolina. 6 months later, we purchased 3 machines, 2 of them in Harrisburg, and 1 of them was down in North Carolina. So, the transitional times that we went through. I started again in 1979, worked in a machine shop, came right out of vocational school, and did a lot of machining. For the first 10 years of my career there, obviously there was no computers. There was nothing CNC, nothing automated. In fact, when we were making terminals back then, terminals were made by watchmakers. That's what we hired. We hired watchmakers to make the terminals. Everybody had tool chests full of different types of pliers that you could bend up, different radiuses, swedges, lances and all that. And when I came in at the tail end of that. So I was kind of a new guy. I was learning a bit about the hands-on, but I came in at where they had the Kirksite pouring, and we were making some EDM burns. We got our first EDM machine, blew that up a few times. So it was nice trial times in the beginning. Then we got into the CNC end. That came in, we got a wire EDM. Obviously, I was the first one to run it. Then we got a CNC mill. Then I ran that one. So the wire I spent 5 years on. The mill I spent 3 years on. Then we got a screw machine, and I spent a few years on that. So then I was watching this additive manufacturing. The stereolithography came into the company at around 1987. Now, we didn't have one in the shop I worked in, but it didn't seem like it was really taking off in the Harrisburg area. And the Harrisburg area was the corporate headquarters for AMP. But what happened was the material that was in stereolithography was the DeSoto resin, extremely hazardous. We should get into hazardous properties later. In fact, somebody is during this here presentation, please ask me why we're not allowing small tabletop printers in our company. But with the stereolithography resin, we had a very brittle resin, and it was really giving stereolithography a bad reputation within this area. What was happening is we'd build a couple parts, we'd give them to the salespeople, they'd go out to the customer, and one of 2 things would happen. They'd either break in their briefcase, or else they'd give them to the customer would break it right away. Immediately, our product was junk. So I needed to turn that around. So in 1989, I learned about the silicon rubber mold building process where you use stereolithography as a master, and then you take and you use the stereolithography and cast around it, and then you produce a urethane part. Now you got a durable part. You have a lot of different properties to pick from, colors, what have you. And that really took off. Management liked it. They said, okay, use stereolithography as a tool and then go from there. So we did. Changed the mentality. Early 90s, I got involved with this AMUG. And back then, it was called the 3D Systems North American Stereolithography User Group. And I'm going to get into a little more detail about AMUG and what AMUG's about. But I got involved with that, and then I found out there's a lot of resin manufacturers out there that were pretty much hungry. And I jumped on board, start to formulate resins with them, especially out of the Switzerland area with rapid prototyping chemicals. They were formulating high temperature resins, they were formulating flexible resins. I was putting them on my machine, we were beta testing them. And the goal was to eliminate this silicon rubber mold building process. Now, with the silicon rubber mold building process, I did create 4 jobs within the company, and I was able to have a hired staff there that were making molds. But you have limited quantity, and there is some limitations to that. The time frame was not quick enough. We needed to get right to the customer as fast as possible, and I wanted to come right out of the SLA machine. So I jumped on board with this user group and said, hey, we need to power the people to push these chemicals to try to get them out to the industry, because it is all about materials. And this is back in the early 90s. And in the early 90s, people really didn't get that too well. But I was like pushing for it. So we all got together, we pushed it, we seen the development of new chemicals, we started seeing them getting into the machines. 3D Systems was working with us, with what the needs of the customer was, and they were implementing a lot of these new chemicals. good things were happening. We were getting parts out of the machines that would simulate the urethane, and that's what we wanted. And we all know it is a photopolymer, and it is limited to its characteristics, but you got some good first article impressions, with that technology. Now, the North American Stereolithography User Group turned into 3D SUG right around 2003 when I took it over. We had a little bit of a hiccup. We're going to get into a little history about AMUG here right now. We had a little bit of a hiccup within the industry where this user group almost died. 3D Systems decided that they no longer wanted to be involved with the user group, so they pulled out. That was our major sponsor. That was $20,000 that was coming into us. And without that, we were not going to be able to survive. So I volunteered to run the user group, and I had some innovative ways of trying to pull some money in, and I did a great job at it, and I ended up pulling in $80,000 that year. So they can go where they needed to go, and we've survived. We restarted, we kickstarted, we got the stereolithography, and we got the SLS user groups brought together as one. Changed the bylaws, changed everything. Kept the 3D SUG logo for approximately 4 to 5 years. And the 3D SUG, the question is, what does the S stand for? It was silent. The 3D UG is really what it was. We left the S in there because we were hoping 3D Systems would come back, because without 3D Systems, the technology that 3D Systems had was not moving forward like the users wanted it to. Prior to that, at the beginning of the user group, we were telling the 3D Systems what we would like, and they would implement it. And it was a perfect marriage. I mean, we were all getting what we wanted in the end. They were selling more machines, selling more materials, and the users were seeing the technology progress. So anyway, they pulled out. So what do? We created this new logo system. We let the S in there. We can call it systems. We can call it solids. We can call it whatever we want. But we left it kind of like silent. So then we decided just to drop it to the AMUG and just open the doors, let the floodgates open, and see what all comes in. Now, the Additive Manufacturing User Group is all volunteer driven. And if you ever look at the byline underneath it, it's something I came up with. It's for the users, by the users. So nobody gets paid nothing. It's all volunteer. It's all about passion. It's all about what people like and where we're going with this. And we really want to make this work. And we want the people that are presenting to be the people that are actually running the equipment, like myself and other people like me. So that was the driving force behind it. Just like coming here. I was asked to be a keynote speaker. I appreciate that very much. But they said, hey, your registration is going to be waived. The first thing I did, I went right to the website, and I signed up, and I paid their registration, because I should be no different than anybody else in here. And this is the way it should be. I mean, the benefits of what we get out of a user group should come from all of us together as a collaboration. And the user group really does that. Now, when I ran the user group, there's around 85 to 87 breakout sessions within a 3-day term. Think about that. Look what we're doing here. We got one main session, and we got 2 breakout rooms. I ran 87 breakout sessions within the 3 days. I mean, that was a feat. I mean, I almost got divorced over it, setting that conference up. But I'll tell you what, we set the stage, and we made the people want to come back. We only had 180 attendees at that time. Today it grew to where we're close to 1,000 attendees. And it's exploding, and it's becoming a very viable source for people like ourselves when we want to look at education and how to drive our business, further and faster. Okay, within 3D printing, I'm not going to get into a whole lot of the details of this. We all know what the benefits are. We've heard about it. We're going to hear more about it. So I just kind of want to go over what we do within the company and what we have. Now, we have fused deposition modeling. All the equipment I have together, it adds up to be close to $2 million worth of equipment. Now, under the FDM line, we have a U-print. We have a Fortis 360, 400, and a 900. And it was very interesting the way we got these machines. We first got the U-print in because we had an intern that came into the company. And, the buzz of 3D printing was taken off right around 2010. 2011. So he came down to me and said, hey, Bob, I'm supposed to buy a tabletop printer for engineering, and hopefully we're going to put them all across the company. I said, okay. He said, what should I buy? I said, you want to buy a U-print? He goes, well, I was told to get a Mojo. I'm like, no, don't get a Mojo. Get a U-print. I'll tell you why in a little bit. So He went ahead and he bought the U-print. He had it for about 6 months. They did some things on it, made some toys. That's about it. Never really made any product. But while he had it, obviously they're right beside me, so I'm running the machine more than they are. And this is kind of my trick to the trade. That's how I get to take over these machines. So I utilize it more than they do, and then eventually they're like, hey, Bob, you're using it more than us. Why don't we just transfer the assets to you and you take it? So they did that. Then they got the 400, okay? Then I did the same thing. I went and used it more than them, and I got to be a pain in their side. They're like, why don't you take it? Then a 900, then I got that. So that's, I started out really with no equipment within our company, and now I have $2 million of equipment because I have not just FDM, SLA, and then the DMLS. Take notice, and I may come back to this. I'm just kind of dwelling here for 1 minute because I'm thinking about telling you about what I call satellite printing. The U-print I have set up as satellite printing. I'll tell you real quickly. I have 50 people, 50 engineers in my company worldwide that access this printer. And I coined it satellite printing because if I'm designing a product and I'm working with an engineer, and the majority of our engineers are, say, in Harrisburg, but my design may be coming from anywhere in the world, anywhere. So what I do is I give the designers, the drafts people, the access to this printer, set them up with the IP address and everything, the software, and I don't even talk to these people, just 3 little simple emails of how to get started, what to do, and how to print a part. When I see them print a part, I know they got everything set up. So there is no such thing as a communication barrier. It's all email, it's all taken care of. So this is working. I have 50 people around the world printing to one printer in my area that they had no official type training. That's how easy this could be. So engineering, they'll just walk down, pick up their model, and go. Now, obviously, everybody knows there's supports on these models that got to come off, so that's where we come in. I got a team of 4 of us that work together on the equipment, so I go out and see the parts coming off the machine, off the U-print, pull it off, put them in a sodium hydroxide, clean it, set them on the pickup table, then whenever the engineer needs it, he just comes down, picks it up. Satellite printing. So where are we going from there? Well, the next one's going to be cyber printing. It's not set up yet, but that's my vision of the future. My vision of the future will be you put a zip code in and you pick what technology you want, and your customer or engineer or whoever it may be, will go to that area at that address and pick up their part. Think of it as the Uber of additive manufacturing. Can it happen? Absolutely. Are we going there? Heck yeah, it'll be there. It may take a little while, but right now we'll implement the satellite printing and go from there. Okay, some of the materials that we run all the materials, all the ABSs, polycarbonates, PPSF, which is not on this list, all temps. So we are instrumental on all the materials, always looking at new materials. What do we make? We make a lot of different things. It could be anything from fixturing to product to concept modeling to covers. And I'm going to talk about fixturing just for 1 minute because everybody's talking about fixturing, and I want to tell you how I ruined a piece of equipment because of making fixturing. We do a lot of testing and analysis of our connectors, and we do it in salt spray, and we do it in different kind of chamber environments. And what had happened was I was making ABS fixturing for them, and I coated their material, or their chamber with some material that was unknown, and I ruined their chamber, and I got chewed out bad for this. So we started doing some analysis of these materials that are running in these FDM machines, and they're not the real material. ABS is not really ABS. Polycarbonate is not really ABS or polycarbonate. All temp is not really all temp. There's a lot of additives in these materials to get them to flow through them tips. So now what are we going to do? So now all of a sudden there's a big halt that I can't make fixturing now for testing. So now we got to start looking at materials, and we keep talking materials. Absolutely. It's got to go that direction. But how are we going to get them to flow, and how are we going to get them formulated to where they'll work in the machine, and how are we going to get open concept type machines, which so many of these are closed concept? My fault, too. I wanted the closed concept machines in the very beginning. Orthography first came out. It was too hard to run. It took a special technician. I wanted push button technology. I really pushed to get it to where any person could walk up to a machine and get it to run. Okay, I hurt myself. Now I can't run alternative materials because now it's all locked down. Okay, we'll get there. Stereolithography, I'm running 3 materials right now, Prototherm, Accura 60, 9120. You know, it just works really good within connector design, whether it's high temperature, whether it's flexibility, or, you know, if we're looking at clarity, if we want to see through a connector, want to see some contacts, what have you. Yeah, we do have a Projet. The Projet and the Connex, which I'm going to talk about both of them, are competing technologies. I evaluated both of them. They're both monomer jetting. We talk about, you know, polyjetting. Polyjetting is just a jetting technology, and that's coined by Objet, but it's really just a monomer jetting. I picked the Projet because the Projet had a finer resolution and gave me a better quality product when I took the two of them head to head. Connex was the other one that you know, we just currently just got, and you know, I'll get into why. And we're doing a lot of the molds out of the Connex, and I'm going to show you in a little bit how I worked with the university to find out, you know, which is really better, Connex or stereolithography. So that's the results of that is pretty outstanding. DMLS, wow. I sat in a couple sessions. Imperial did a great job. Yeah, the powder metal is very, very expensive. We were the first people in the world to actually put the technology in its proper environment. It cost me $200,000 to build a room within a company, within a building, just to put the machine in that room. If you take that machine and the materials of that machine and you read the MSDSs, you got to eliminate all sources of spark. This stuff will explode. Yes, you cannot use standard vacuum cleaners. I know a couple of them that have exploded. I know one that exploded at a university. I'm glad nobody got hurt. I know another one that exploded, and yeah, the guy got burnt 95% of his body, and the place burnt down. And there's been other case studies like that too. So we got to be careful with the technology, and there is different materials that are flammable and some that are not flammable, but if you're going to run the titaniums, the aluminums, the highly volatile materials, you got to make sure you're set up in the right atmosphere. ESD floors, you know, again, the right atmosphere with the right moisture in the air and all that, so you have somewhat of a controlled environment for the technology. Quick turn molded parts. We do an awful lot of these silicon rubber molded parts. How am I doing time-wise? Doing good, okay. With molded parts, if you take notice to this slide right here, if anybody's thinking about getting into molding some parts, this little press right here is a real beauty. You're talking about only $1,000. You can make any kind of mold out of any kind of technology, throw it in there, throw a handful of pellets in there, squeeze down on it, and make a part. Man, if you want to get into the molding some quick turn, you know, simple pieces, you know, even at low temperature, that's it right there. It is out of Allentown. I don't know the name on it right now. I didn't expect to highlight it, but if you're going to look at molding, that's a nice little segue into it. And this part right here came out of that press. Now it's a DMLS part, mold, and it's just an overmold of a cable, which of course we do a lot of those. This right here is a Projet part that has been plated, as well as that's a Projet part that has been plated. The part that's laid inside of it that has been casted is a urethane material. Now, if you're looking at longevity of your molds, plating them with a zinc, or not a zinc, but a nickel over copper is the best way to go. I did not find anywhere when I do this, so I can run hundreds and hundreds of pieces and not see any deterioration to the mold. So that worked out really good, where if you don't coat it, you may get inhibited problems, you may get you know, some deformation of your part, you may get some you know, some wear to the mold, and you're going to limit your life. But you can plate any of these additive manufacturing plastics. So don't let anybody think you can't. The challenging one that the platers are having with is the Objet, because it uses a water to spray off the material, the support structure, and that water kind of inhibits some of the plating properties. Okay, next thing I want to get into, which is really more important, and really what I want to talk about, is how we are working with the community and working with the educational system. You know, going back quite a few years ago, we donated some printers to Harrisburg Area Community College, and when I donated the printers, I didn't expect to walk into a room and see a mini ejector mold press sitting there. and it was brand new, and it was fairly old. I'm like, do you guys even realize what you have here? I'm like, this thing is beautiful. I mean, it's perfect from going from that tabletop system to something a little more automated that we can do higher temperature materials. Okay, so that brings me into why I got this internship going. Now, what I did was I had them do a comparison of polymer molds. It was a head-to-head study of Somos Prototherm, which comes out of stereolithography, to the digital ABS, which comes out of the object system. I got this local internship started. I'll call it the class because they have small classes. They had this class shadow me Tuesdays and Thursdays, 2 hours each day. So it didn't take too much of my time, but I set up this project that I wanted them to go through. And it was a very, very intense project. And what they had to do is we had to build the molds out of both technologies, and we built 10 molds each. And out of the 10 molds each, I wanted them to shoot a thermoplastic. Now, we're not just shooting any old thermoplastic. I'm going to shoot a PBT 30% glass. I want this to fail. I want this to go down. I want one of these technologies to shine. Damn, what happened? Let's see here. Okay. Got the team working on it. They had to, again, shoot 25 shots out of every mold, which was their goal. And it worked. And it worked on both technologies. And they got 25 shots out of both technologies with every mold. I would have never guessed that. Come on, we're talking 600-degree plastic into a plastic mold, 30% glass. When I looked at the stereolithography molds, I ventured to guess maybe 7, 10 parts. I did this stuff in the 90s. This is nothing new to me. And I figured it's gonna, it's gonna have this what's called thermal shock. It's gonna break the mold. It's not gonna work. Well, it did work. And it not only did work in the stereolithography, but it also worked here, in this Connex digital ABS material. So what they had to do, and you see the team there working together, and what was amazing about this team is that when they first got together, it was, these are not canned shots. These were real shots that I stood back. I must have taken about 50 shots just because I was impressed of how these young people were so in tune with each other and really into this project. And they all found what job they should do, whether they're going to be spraying the lubricant on the mold, whether they're going to be shooting the mold, whether they're going to pull in the inspections, whether they're going to be checking the thermal testing. Everybody picked their own little job. But in the very beginning, when they first got together in this area, they're just like, and I'm thinking, oh, no, this is not going to work, because they're not interested. As soon as we fired the machine up, as soon as they seen something going on, they were in it, full bore. Obviously, what you have to do with any kind of plastic mold, you got to watch the thermal of it, so you got to make sure it comes down at the right temperature before you did the next shot. So that we started up a process of shooting these molds. We would cycle with 3 molds. We'd shoot one mold, set it aside, collect the data, shoot the next mold, set it aside, collect the data, shoot the third mold, collect the data, then we'd come back to the first one and cycle that back through. But by then, we found out it was down to the manufacturer's recommendation of temperature to go for the next shot. So we talked about the materials and the people. This was really a great endeavor. Timeline, we did it at the beginning of this year, so this is new information, I'm telling you. It's, to me, for what I'm looking at, it's a groundbreaking thing when we're looking at high temperatures into these molds. Yes, there's limitations with geometry, we all know this, but we're working with some students here. They wanted to prove something out. Now, what did they work with? Obviously, like we talked, they run the Connex, the stereolithography, and the mini ejector right there. Okay, so data. What we're looking at here, and I'm not sure if you'll be able to see it. Let's go one more. Can you see there's 2 different color whites here? I don't know if you can see that from the back. There's like a core here, and this is a core. Well, digital ABS, which is a Connex machine, produces a hard crust on the surface, and then it produces a filler, which is, an inexpensive material that, it's just for that, a filler. Stereolithography is hard all the way through it. Now, don't look at this bow, how this bent over. That's just a photo. That's not realistic. The parts were straight. But we were just showing some of the dimensions on here and how the dimensions were comparing here, the variance of dimensions of the prototherm over here versus the digital ABS over here. So you can see there was a little more range difference in the two technologies that really gave us a differentiation of accuracy and controllable accuracy, if you want to call it that. And that range that we're looking at is over the 10 molds. So what they had to do with their data comparison, they had 10 molds each, over 2,000 dimensions that they had to collect the data and graph for me. They had dimensions on inside, outside, and the results. Now, obviously, there was more data than this, but I made this simplistic. So what we're looking at over here is we're looking at the prototherm, the pink mold, the red mold. We're over here, we're looking at the digital ABS. So really, what do we have? We have some consistency. You know, we have definite consistency along here. If you look at the variance, very little bit of variance within stereolithography. And that's from 1 shot all the way to 25 shots. Well, how about the digital ABS? Well, oh my gosh, not only does it vary a lot, but now we're losing our dimensional accuracy. It looks like our dimensional accuracy is only from 1 to 5. And then from 5, it starts to go. Well, that's exactly what happened. So what do you say? Do we say stereolithography is better than digital ABS? Well, that's kind of we're human. It's the first analogy we come up with, and management catches it that way and says, yes, we don't need, these Connex machines. We can do it with stereolithography. Wait. That's not true. Stereolithography, doesn't it take a technician to run? Connex? I can get anybody to run that in 5-10 minutes. Okay. So I get 5 parts out. I can get 5 parts out. Well, that's cool. That died. So I can get 5-10 parts out, really quick with a Connex, within a day or 2 days. Stereolithography is going to take me maybe 3-4 days, make sure I got a technician available, running it in a machine when it's available. It's obviously not as fast. Yes, we don't have the dimensional accuracy as good on the digital ABS, but maybe we can give that up a little bit. So what are we doing here within my company? I'm giving choices to the engineering. I want them to really understand that you don't have to do it this way, but there's 2 ways. If you got a customer you want to get to immediately, and you need a part you need to deliver, and he wants real properties, he wants to test that part, okay, if our time frame is very, very short, like it is in today's world, I'm going to need to do that in the digital ABS, because I'm going to have to do that quick. If they say, oh, I need 100 pieces, then I might say, wait a second, we're going to look at stereolithography. Let's put the investment in the front end, a little more time to get this done. Then I can give you a lot higher quantities. So really, why don't I just go to digital ABS and do 4 molds, 5 molds? It's that simple. And just switch the molds out instead of doing it out of stereolithography. Exactly. So I added more confusion to it. That's fine. It's all about choices, really. And that's what I'm trying to get in front of our management. If we look at the data range, if you're looking, the variance and the actual dimension, the top one there is the digital ABS, the bottom one's prototherm, the bottom one, again, prototherm being the red material out of stereolithography. If you look at the deviation from 1.2 to 0.09, okay, it's not too bad. But if I look at the top one, 0.22 to 0.28, yeah, that's pretty bad. Connector design, that's pretty bad. So we got to take that into consideration. We got to learn how to overcome that. So, where are we actually going from here? Well, we brought 2 more of the interns, 2 of the same interns of that group back. So they're back for the summer. And we're going to continue to study to figure out where we're going to go. I'm not sure what we're going to do with it, how far we're going to go, what we're going to try to accomplish, but we're going to continue on with it because we think we're on to something here, something new, something groundbreaking. Most of these here molds that are out there and they're being promoted are for the lower temperature materials. So here we got the higher temperature materials. One thing out of that group, and I keep it with me, and I've had a lot of interns, and this really hit me to the heart. I couldn't believe it. I got a thank you letter, which I get a lot of them, but this particular one, and I circled it up there, and this is from the guy that actually headed up the group. And he said to me, he says, and you can follow along if you wish, it says, your passion for what you do and your love for additive manufacturing is infectious. The skills you share with me has already given me the chance to have several additive manufacturing interviews. This was within 2 weeks after his intern was done. This is powerful. I made a difference on one person's life. And the 2 other guys came back to us again for more internships. And this is a community college. This is cool stuff. So I'm really excited. All right. Did we build a motorcycle? Absolutely. Did I bring it along? That don't fit underneath that there, in that there cover. We'll talk about that later. Okay, why did we build a motorcycle? Biggest controversy in the world. I ran it on my 900, didn't want to talk about it much, didn't know if it's ethical. You know, we make connectors, we don't make motorcycles. But when it really comes down to it, it's an engineering feat. We really made a motorcycle that ran. And what's going to happen now? Yeah, we put in a lot of different articles. Yeah, we're getting a lot of press over it. And does it actually work? Absolutely. It's going to be put in the Guinness Book of World Records. After it's getting put in there, I'm hoping to get it in my facility so I can use it as a training tool to show. But what the company looks at is it was an engineering feat, is what can be done with additive. It's not whether it was a connector or not, but it's what we could do. And we did it very simplistically. And you look at that bike and you say, okay, what is not printed? Obviously the discs, but we water jetted them. The electrical motor, the wires, the actual mirrors, the tires, and that's about it. Yes, the bearings are printed. The bearings that anybody picked up, yeah, if you picked up one of these bearings, those bearings are a downsized scale of what's in that there. The bearings don't have to be roller bearings. This here was pretty unique, and we put them into the wheels, so they're on both sides of the wheels. It's with all the technology. You got ABS, you got all temp. There's some PPSF on there, blended ABS PPSF. No, the polycarbonate ABS is what it is. But the headlight, the forks, you see the chrome on it. Yeah, they are ABS, and they were plated, and they shine just like chrome. Pardon? It's made out of ABS. It's the blue ABS. Yep. The funny thing about this bike is we made it, we took it to Rapid, we showed it, and a gentleman that brought it back, he rented a van and a U-Haul, and he ran into a bridge, and it was in the U-Haul. So the frame broke because the tie-down straps, it broke. So we had to build another frame for it. But yeah, now, when you ride it and you sit on it, does it feel like a bike? It feels like a printed bike. You sit on it, it's like, man, it's like a wet noodle. And you ride it, it's like, whoa. So yeah, it's not something that I'm going to take down the street. So it goes 10 to 15 miles an hour. It's 8 feet long. It weighs 250 pounds. A little bit of statistics on it. It was a fun little project. And again, we're getting a lot of press on it. The article's there. So we're at time-wise here. We're good. So let's talk a little more about additive manufacturing. How's it working really for TE connectivity? Is it doing good for product or for infrastructure? First of all, does everybody understand what infrastructure is? Infrastructure is the fixtures, the secondary processes you do with additive, not necessarily primary parts that come out of it. Am I making connectors out of additive? No way. I only got one qualified part that I can say that is truly a production part, and it's a camera holder for one of my equipment for the corporation. My machines are putting out a minimum, and I can't give you the exact number, but my machines are putting out for the last 15 years consistently 20,000 parts, per year. That's a lot of R&D. That's a lot of new development that's going on. And only one is qualified production worthy. Why? Well, it really comes down to materials. We're back to that old, snake oil. How are we going to get that to really work? So what we're looking at is there's a lot of value in infrastructure. We talked about the molds. Yeah, we talked about some of the fixturing. We'll get over that. But really, I see us getting more into the infrastructure and how we can implement the 3D printing, the additive manufacturing as a secondary source to product, not the primary source of the product, is what we're really looking at, okay? And again, we'll talk more about that when it comes to the session later on. Okay, I'm going to speed up here really quick. Let's talk about quality control. One of the problems that's been coming up lately is people are saying, well, you're not consistent with your quality, you're not consistent with your accuracy, how do we control this? Well, Brian, do me a favor, hand these out. I'm a little bit premature about this, but go ahead and hand these bags out. These bags have some of the parts that the students had made, and I want everybody to take a look at them. The molds are in there. Pass them around. Check them out. Now, I want to talk about this inspection part. I needed to come up with a part, and now that I got a team of people working together, we got to find some consistency, and the consistency cannot be measured through mechanical means. It's got to be something visual, something quick that you can say yes or no, it's working. So what we come up with this little block design, and I got a few of these that you can take a look at, and within the block design, there's some cavities, there's some thin webs, and what it's going to do, it's got some color to it. And it's going to analyze to me real quickly when I look at it, did my machine run properly? I can measure this overall. It's got to be 1 inch by 1 inch. If I'm not 1 inch by 1 inch, I got a calibration problem. If I see that little web inside there and it's all distorted and flexible and not truly straight, let's see if I got like that, you see the web in the center. That tells me right there I got a post-processing problem. Somebody put it into alcohol too long, or the polyflush too long, or the TPM too long, and they weren't watching what they were doing. That tells me definitively you got an operator problem. The circled areas right there, I'm not really sure if you can, circled areas right there, I'm not sure if you can see them, but there's still resin down inside those cavities. Okay, this particular part, it was not left in the post-processing long enough. Now the cavities are not getting cleaned out. So where do you draw that line? That's where we're starting to implement a study now of this here calibration piece, and we're carrying this calibration piece along with every part that we run. Now we're starting it in stereolithography, but we're going to start doing it in all of our other technologies too. That's what I got. What do you think, guys? Okay, questions?
What was the cost of printing motorcycles?
Wow. Put it this way, I wouldn't want to buy it. I think the last time I actually added up, I think we were looking at close to $30,000 for the motorcycle. Yeah, being a one-off like that, the frame alone was $9,000 just for the frame.
You mentioned earlier on that there was a particular reason why you didn't allow desktop 3D printing.
Thank you. Question was, why don't we allow desktop 3D printers? This comes in a safety aspect of it, and I'm glad I mentioned that. I'm glad you thought enough to bring that up. Well, I did a fine particular analysis with an outside company within our company on all of our printers. We looked at all the Fortis lines, that are extruding. That's really the ones that's going to put out any kind of fine particulates. And we're talking nanoparticles. And then we're looking at these small tabletop units. And the question is, and I've always had a concern from day one, you're running plastics, and the smaller units, you can tweak everything. You can over temperature it, you can under temperature it, you can feed it too fast, you can feed it too slow. You're going to leave all the control up to an operator, and you can put it on his desk, and you put it in front of his nose, and is he going to get cancer? Well, major concern for me. I'm the environmental safety person within our building, and I'm on quite a few of the corporate staff committees, and I threw this flag up, and we got this analyzed. And indeed, there is microparticles coming off of the small units, and there's nothing coming off of the Fortis units. Amazing discovery. I put all the different materials into my Fortis units, cranked the temperatures up, tried to run it to where I can, I'm laying down plastic with a T20 tip, and I quick open up that door, and I throw that monitor in there trying to find particulates in there, and I can't find nothing. I'm like, this is not what I expected. I expected to find some major hazards within the large commercial systems. But we're finding the hazards coming from the small systems. And don't put your nose any closer to that nozzle than 7 inches. Seriously, because once you get closer, we maxed out the meter with the fine particulates coming off of these units that were like 3 inches away. Now, we looked at the Solid Doodle and we looked at the Affinia, were the two of them that were open architecture that we could really get in there and do some monitoring with. And the fans that are on them, that are cooling them tips, they're blowing it right at you, so stay out of that air. So if anybody in our company wants to buy one of these and wants to implement it, number one, they got to enclose it. Number two, they got to ventilate it. So we've already made it a standard within our company, corporate-wide, that no desktop printers are allowed within the company. Doesn't matter your atmosphere. If it's going to be in there, I don't care if it's in a shop, we got to have it, controlled. We care about the people, and we should continue to care about the people. So as an FYI, cautiously, be careful of it. Stereolithography was the same way back in the 80s. The DeSoto resin, you got a pamphlet with it with skull and crossbones on it, has been proven to cause cancer in laboratory rats. And I look at that, I'm like, I'm running this stuff? I've quick ventilated my room because I wanted to be around, today to talk about these technologies, and that's one of the reasons why we pushed away from the DeSotos and got away from the acrylates and went into the epoxies. At that time, we found less hazards within epoxies, than what the initial ones were. Thank you.
Question: how important do you think it is to do things like the motorcycle? You said it's really not about building the bike, but showing what the technology is capable of. How important is it to do things like that?
I think it's very important. From the motorcycle, one of the other things that we built was a brutal press. We do a lot of presses, a lot of stamping within our company, making contacts. So we bought the 100th press off of Bruder. So we actually printed a functional Bruder press. Now, it didn't really stamp, but it was movable. It had a motor on it and everything. It was kind of cool. And we gave it to Bruder, and they put it right in their front lobby area, their main headquarters. It is very important. It is very important because now it's not just coming from us, but anybody that walks into that lobby in a Bruder, they see this miniature press, and it's 3D printed. It's what the society is about, the direction we are going. Yes, there's limitations with everything we talked about, and we're going to overcome these. Will we be able to print a connector one day? Absolutely. At one time I said, no way. But I'm involved with some operations now that I can see it's definitely there. What, we got to do it soon? No. But when are we going to do it? Satellite printing. We implemented it within my, how much? Okay. Within my company, we looked at the satellite printing. Where are we going to go from there? Maybe the next one is going to be putting these printers at our customer sites, and our engineering and salespeople can print right at the customer sites. Maybe one day we'll have a printer right at the customer site. The customer needs a connector. He tells it what he needs, and it comes out as a standard connector. Who knows where we're going to go? But yeah, there's definitely a future there.
Did you do any safety testing on the cons functions?
No, we did not. No, we did not. I am concerned about that because the parts do come out of that machine sticky, and anytime you get around any kind of acrylates or epoxies, when they're sticky, that means you're touching raw resins. I am sensitized to the resin. I've been around a long time. Everybody got different level of sensitization. When I'm sensitized, it's not a big deal. I just get a little bit of rash on my hands. I just, it goes away in a little bit. I just stay away from it. I usually get it from stupidity if I touch raw resin and not actually wear the gloves like I'm supposed to. My own stupidity. Okay. We good, Don, or? Okay.